Okay. Good afternoon, everyone. Thanks you for coming to this session. My name is Igal Edry. I'm a program manager in the Windows Server organization. In the last 3 years or so, I've been working on the area of how to build clouds using Windows Server. How many of you have been to one of my sessions when we launched Server 2012? Can you raise your hand? Only one. Okay. So for you, it's a little bit of a recap. For everyone else, I guess it's completely new, which is good because I really wanted to re-emphasize the Windows Server 2012 story and then build on top of that and talk about what we did in R2 to improve the ability to use Windows Server as the platform for building a cloud for hosters, service providers. That's really going to be the topic of the talk. So let's get started. We'll talk first about the Windows Server 2012 capabilities as the cloud infrastructure. What did we do in 2012 to make it a great platform for building the cloud on? We'll talk about the improvements in Server 2012 R2. We will cover some of them. I've selected those that I thought are really important to highlight in the context of this problem space of you want to build a cloud infrastructure, what is new in the platform to enable you to do that. We'll spend most of the time in this session to talk about how to design the infrastructure. What are the considerations you want to go through? If you're going to build your own cloud, what are the considerations you need to go through and how to think about this problem? And then Hector from the System Center VMM team is here to help me do a demo, which is also something that we can highlight about as one of the things that are actually new in R2. After we've covered the basic of the infrastructure, I will give you some pointers for how to do things that are beyond just the Windows Server as the platform. So we'll talk about how you scale. We'll talk about network connectivity. We'll talk about the management stack. I will try to give you the right pointers. And one of the key goals here is really to help you see the big picture of if I want to build a cloud, what do I need to think of? And then within that, point you to the right places for the different technologies. There is no way that we can do all of them as a deep dive in one session. So in this session, we will try to go deep into the infrastructure piece, and I'll give you the right pointers for the rest. Hopefully, you'll find it useful. So let's get started. So Windows Server 2012. When Windows Server 2012 was designed, the key goal there was really to make sure that we are building a great cloud-optimized operating system. And that means it has to address the needs of someone who wants to build a cloud based on Windows Server. So we thought of this as a combination of 3 pillars or 3 key areas of investment. If you want to build a cloud, you must be dynamic and multi-tenant. The environment of a cloud requires you to run a lot of different tenants on the same infrastructure, move them around. We need to think about the dynamic aspect. The second thing is a cloud obviously is something that has to run at scale, and we invested a lot in enabling Windows Server to become a very high scale at low cost platform so that you can build your cloud to be cost effective. Last thing, if you are building a cloud, everything needs to be manageable, automatable, and also extensible to allow for additional scenarios to come in through partners, and we invested in making the platform exactly that. If you've been to one of the sessions when we launched Server 2012, this is really what we started to talk about. Going from left to right, in order to make it dynamic, we introduced Hyper-V network virtualization. We introduced ability to isolate between tenants using policies and quality of service policies. We introduced the ability to move VMs and storage around, so live storage migration was new. We introduced the ability to do cross-premise connectivity. All of these things were meant to basically give you the key capabilities for making a dynamic multi-tenant environment. Then we thought about how to run it at scale. And when you think about scale, you think about scale on the compute side, on the network side, and on the storage side. And we had a series of investment in Server 2012 to enable that. So support for much larger hosts, larger VMs, support for new types of networks, 10 gigabit Ethernet, a lot of offloads to make the network run at scale while not consuming CPU cycles more than it has to. And also in terms of storage, we've introduced Hyper-V over SMB as the first time where you can use low-cost storage. If you combine Hyper-V over SMB with storage spaces, you can build low-cost storage for your cloud environment. So these were kind of like our thinking around how you scale and drive while driving the cost down in the compute, network, and storage space. Next, if you think about management, really the key thing that happened in Server 2012 is the amount of support that went into making everything automatable through PowerShell. 2,300 plus new commandlets, everything is automatable, and then also extensible. You can extend the system either by managing it through PowerShell and doing new scenarios, but also extend the Hyper-V switch, gain access to traffic going through the switch, get visibility into traffic between VMs. All of these things were enabler for the scenario of building clouds using Windows Server. What you don't see here is the full solution. What we've focused on in 2012 was really building the right platform, and then use that as the foundation for building on top of that a full solution. So let's see what we did in 2012 R2. First of all, we continue to improve the platform. There are things that we can do better, and we continue to drive that to be more efficient, more scalable, faster. All of these things are really critical to enable you to build clouds using Server 2012 R2. So live migration became faster by taking advantage of RDMA. We also enable you to easily migrate from 2012 to 2012 R2 with live migration across versions. We've introduced support for shared VHDX support, because if you're going to run a cloud and you're going to rely on SMB storage as your primary storage, if your guests are going to require different types of storage, SANs, iSCSI, Fiber Channel for guest clustering, this storage is not going to be around. So now you have shared VHDX to enable your guest VMs to actually do clustering over shared files, basically. On the storage side, we've improved the performance by introducing features like storage tiering, write-back cache. We've improved the performance further for scale-out file servers by including features like per-share redirection. So if you have a Hyper-V node or any type of client for SMB addressing a share on a scale-out file server, it will find the route to the right server that hosts the share, and performance will improve as a result. If you go back to if you continue to network, then one of the key things when you run a multi-tenant environment and once you use Hyper-V network virtualization, you want to enable those tenant VMs to connect out either to some external network on premises or just to physical host on the network. And we needed to enable that as part of the scenario. And in Server 2012 R2, we've introduced multi-tenant site-to-site VPN gateway that also support Hyper-V network virtualization. So now you have that in the box as a Windows Server feature. NIC teaming improved to support a better balancing for network virtualized environment, and some other features. On the management side, we basically invested in new management infrastructure capabilities that will enable you to better manage a data center environment or a cloud environment. One key capability is called DSC, Desired State Configuration. It's an extension, think of it as an extension to PowerShell that allows you to describe your desired state of a system instead of writing a workflow of how to get there, and then the system will keep the host where it's running on in this desired state. So smart descriptive language of describing how you want the system to look like. And then we invested a lot in abstracting the way you manage the data center across multiple devices in the data center, both compute, storage, network gears. They all need to have some standard way to access them, because that allows us to then manage the whole thing in one unified way and simplify the management stack. The next big thing that really happens in this release, beyond the improvement in Windows Server, is really the fact that for the first time, Windows Server and System Center are aligned, shipping together at the same time. So if in Windows Server 2012, the focus was let's build the infrastructure, in R2, the focus is let's build the infrastructure and the management experience on top of it together, so that when you get your hands on the bits, you can actually get the complete solution, both great infrastructure as well as great management experience that can manage it. So this is really key. In my opinion, this is probably one of the biggest things we've done beyond just Windows Server, and I'm a Windows Server guy, and it is really one of the key things you need to take from this release, which is we are together, we've even organized as one big org. Windows Server and System Center, organizationally, now belong to the same organization unit. So these are the improvements in a nutshell. And assuming you see that there is a lot of potential here and there are a lot of new features that are enabling to really build an efficient infrastructure, what I want to do now is really walk you through the thought process of how you design a cloud using Windows Server and System Center and start with the infrastructure. And for that, I would use, before that, the ground rule or the scenario that I have in mind, and the one that we will use here for walking you through the process of building this infrastructure is that you are a hoster, service provider. Maybe you're an enterprise, but even within the enterprise, you're basically acting like a hoster to your customers. So think of it as a hoster. You want to offer infrastructure as a service to your customers. The customer may be external customers. They may be internal departments. Very similar problem space, right? You want to enable them to go in and ask for infrastructure services, and you want to do this in a way that is requestable, meaning the tenants can go in and request for resources in a self-service manner. You want to make sure the infrastructure is available. You want to make sure that you can actually charge for the usage of this infrastructure. You want to build it in a way that will scale well, and you want to do it all in an attractive cost, right? Otherwise, as a hoster, you're probably not going to be very successful. What we will do here is we will build it on Windows Server and System Center. And we will go methodically through how a system like that looks like, and either drill down and talk about the specific design cases where it's a Windows Server area, or point you to additional sessions where it's beyond the scope of what can be done in a single session. So let's look at a blueprint for a hosted cloud. You really start with the management. You want to start by thinking about what your management stack is going to look like. What are the capabilities you need? You need to be able to manage the fabric, etc. And you set up some management stack that we'll talk about later. You rack it up in some rack. You connect to it, and you start provisioning your capacity. And your capacity is really your compute nodes and your storage. Once you do that, you want to start scaling it and adding more and more capacity. You can add more compute nodes. You can add more storage. You can add even more storage than compute, depending on the needs that you have. The amount of compute capacity you'd want to add or the amount of storage capacity you'd want to add may change. So you want to grow your system as your business needs grows, right? We'll call this internally at Microsoft, we tend to call this thing a stamp, which is like the unit of a cloud that is both management, compute resources, storage resources, all kind of like one big unit. Sorry. Once you have that basic unit, you really want to start allowing your users to use it, right? You'll probably start allowing them to use it when it's smaller and it will grow, but for the purpose of simplifying the scenario, you want to enable them to connect to that management and consume the resources that you're offering them. They will start putting VMs on the infrastructure. So now your tenants are actually active and consuming your compute capacity. And once your VMs are actually working, they probably need some access to the outside world, either to a physical resources or through the internet to their own premises sites. This is really what you want to build. What we'll do is we will walk through the pieces here, and I will try to show you how to think about designing them or which technologies, which sessions you want to go to understand that piece better. So that's really the flow of this session, and let's get started. So we'll start with the infrastructure. The infrastructure is really your basic compute and storage nodes. This is where most of the Windows Server 2012 investments were happening, making that unit, or these two units, highly effective, highly scalable, highly performant. And if you look at the different features that came out in Server 2012, there were tons of them. New support for hardware acceleration features, for features like NIC teaming, network virtualization, spaces, now tiering in R2. What I want to try to do is help you understand the context of where these features are actually usable or useful for this design of a hosted cloud problem. So, if you're a hoster, you basically have your set of requirements, right? You think about what is the cost target that I have, what are the scalability goals I have, what reliability, performance, security, high availability, all of these things are requirements that you need to think through. And an easy way to think about them and to break it down into areas for consideration is really to talk about 4 different problems, 4 different consideration areas. You want to think about the workloads that you're going to run on this cloud. You want to think about the network infrastructure that you are going to build in order to build this cloud environment. You want to think about the storage architecture or storage approach that you're going to have. And you want to think about resiliency. What do you need in terms of resiliency from the infrastructure in order to build a cloud environment? So let's walk through each of these one by one and understand what they mean in terms of actual, practical consideration or decisions that you will make, and how the different features in Windows Server 2012 and R2 are going to help you achieve your design goals. So we'll start with the workloads. One of the things we said in the, I'll call it the pre-cloud era, the virtualization era, was you always start with the workload. You understand your workload. You understand if you're designing this infrastructure for running SQL or SharePoint or Exchange. And that's your starting point, and from there you'll derive your design. In the cloud area, you really think about 2 things here. You think about whether the application is cloud-aware, stateless, knows how to handle failures by itself, or is the application some traditional application that expects some resiliency from the infrastructure. You can build an infrastructure service cloud to support both. There will be some slight different design consideration, but you need to understand what exactly do you want to do. For example, in Azure, the design point is that the application will handle its own failure, or the fabric of Azure will do it at the application level, not necessarily at the infrastructure level, right? In other cases, if you're going to build a cloud to host traditional SharePoint, Exchange, Link, etc., you may want to drive this failure design or high availability design into the infrastructure. And in IaaS, you really are managing servers. You're not managing the actual application. The tenants own their applications. You're managing servers. It's a good way to think about that. You do need to think about whether you have workloads that you're expecting to run that will have unique performance requirements. In general, 2-socket servers are the best ROIs today. Large workload will run well on them, but if you have a very, very large workload, maybe you still want to do something unique for that. Usually, just if you're thinking about this problem of an IaaS cloud, you really want to think about 2-socket servers, standard, best ROI. There are some areas where, again, you will have some workload that will require some special capabilities, like maybe SRIOV for high network performance. If you need that, build it into your design and be ready for that. Then there is a question of a trust on the workload. Basically, can I assume that my workloads are fully trusted, or do I need to think about this as I have the infrastructure, and I have workloads that belong to some tenants that I don't trust? As part of my role, I go and talk to a lot of hosters, a lot of service providers, and understand what they are trying to do and how they think about this problem. And one of the best quotes I've heard from one of the hosters was that when they design that, they need to do a good, secure design, and they need to think about the threat from outside, from the internet, but they need to think about the evil from within, the tenants trying to attack their environment. This means you cannot really, as a service provider, as a hoster, you cannot design the system in a way that one tenant that tries to attack you will actually gain access to another tenant's resources. It's critical that you treat your workloads as untrusted in a way. And Windows Server gives you all the capabilities to do that and have great isolation. What this all means from an IaaS point of view, I'm building a cloud for this problem of infrastructure as a service, is that you really can't optimize for one specific workload. You have to build something that is simple and manageable and that will run many different workloads, and you don't really know when you start what workloads exactly you're going to run. So you have to design it for good performance for everything. You have to design for enough CPU, enough memory, enough disk space, enough IOPS for the mix of workloads that you're going to host. In some cases, you may want to have some part of your infrastructure optimized for a specific workload, but really think about it as this is a standardized VM that I'm going to offer, some T-shirt sizing. It's going to be self-service based. It's going to be managed to an SLA that I promise. It's not designed for Exchange, right? It's designed for the mix of workloads. Some of my tenants will actually run apps that will consume these VMs and will run their own apps. I may want to be able to offer some standard templates of business applications, but all of these basically rely on a unified infrastructure and a unified standardized VM approach that you're going to offer. So this is really, from the workload perspective, a key thing to have internalize, that we are past the days where we are designing the infrastructure per workload. We want to design something that runs everything well. Let's talk about the network design. Back to the key design goal, that you need to think about isolation and you need to think about tenants versus my infrastructure, or the outside world versus what I control. The traffic types, or the type of traffic that you're going to see in your environment is really can really be divided into two. There is everything the tenants do, so the tenant-generated traffic, which is going to be likely network virtualized or running over some VLANs, but it's really the tenant VMs are generating this traffic. And then there is your traffic as the hoster. Your traffic meaning the traffic that your Hyper-V hosts are going to generate for their own purpose, the clustering traffic, the storage traffic, the live migrations that you're going to do, the traffic for management. This is kind of like yours. And you want to think about using the different technologies in Windows Server in a way that will allow you to do two things. I actually start with the two bullets at the bottom, which is you want to have good separation between your tenants and your data center traffic, or your own traffic and the tenant's traffic. And you want to have good separation between the tenants and themselves. And in Windows Server, we have all of the relevant features to allow you to do ACLs between tenants, VM queues, so that one tenant cannot attack another or cannot overconsume resources. You can use Hyper-V network virtualization to isolate between tenants and even allow them to share this, have same IP address spaces but not conflict with each other. And you can also use physical isolation in some case. And a place where this makes sense is on the tenant versus data center traffic. It actually makes sense to design a data center where those two are different physical networks. We'll get to some examples that we actually released as part of Server 2012 on guidance on how to do that. And we'll see that this is actually a design pattern that we followed, which is even though you can actually achieve good isolation with cross policies, with ACLs between the networks, separating this out is a good dichotomy to have in mind. And I've also seen many hosters actually do that as the way to really simplify and separate those two areas. This is my network. I can manage it. I control it. I I know exactly what's going on there. It's under my tight control. Tenants do not even have access to that, versus the network that the tenants are using for their own traffic. In the context of network and scale, Windows Server 2012 introduced a lot of new features that are basically hardware offloads to allow you to run high-scale networks and minimize the impact or minimize the CPU consumption from the hosts. And if you just look at the laundry list of them, it's often hard to understand where each is relevant. So I want to try to kind of like use this slide to give you some orientation of where they're relevant, what each of these offloads can do. When you design your cloud infrastructure, you really have to choose like which ones are relevant for me. What am I going to use out of all of these new capabilities? It's not necessarily that you need all of them, but it's good to understand them in order to know which ones are relevant for your design case. This is a 2012 major investment, so there is actually no specific talk on that, but there is a link here that you can then later follow to read more about each of them. But let's kind of like spend the next few minutes understanding each of them in context. One of the key features or key offloads that we supported in 2012 was something called DCB, data center bridging. At the very crux of it, at the way it's implemented in Server 2012, it allows you to do some offload of QoS into the NICs. That's what it does. RDMA, I'm sure you heard a lot about that, allows hosts to basically offload the data transfer between two hosts over the network and offload the processing of that to the network card. In the context of a cloud environment, where you really want it is on the storage path, right? You want, if you have a Hyper-V talking to a file server, and they're obviously talking over SMB, the NIC that is used for that traffic needs RDMA and will benefit from that. If you have NICs that are not doing that, actually not relevant. It's not going to help them. One point to note here is that in R2, we are also using RDMA for live migration. You'll see later that in the design point that I'm going to talk about mostly, these two are basically combined to be the data center network. So on the data center network, you will want to consider RDMA as a good way to improve the overall performance. RSC and RSS and RSC, yeah, are both features for enabling better scale of the network, better processing of network traffic, mostly relevant for the Hyper-V server traffic itself. So think of it as the NIC that will handle large amount of data transfers on the Hyper-V server will benefit from these two features. VMQ is around providing better scalability for VMs that are running on the Hyper-V host, and the NIC that is going to be connected to the extensible switch is the NIC that will benefit from a VMQ capability. There is also ability for IPsec task offload. Again, if you have VMs that are going to do IPsec, you can offload that to the NIC. Again, logically, it makes sense on the NIC that is supporting the VMs, right, and not on the NIC that is supporting the Hyper-V server, for example. Another feature that we introduced in Server 2012 was called SRIOV, which basically allows a VM to get direct access to the NIC, bypass the switch, and get better network throughput, better latency. And SRIOV is relevant on that NIC again, the NIC that goes to the VM. Note that if you enable SRIOV, you bypass the switch altogether. So any switch features become not relevant in this case. This is one more example of cases where you're designing an infrastructure. You need to think about this interoperability between the different offloads and make sure that the selection you make on which offloads to use will actually work well together. We'll talk about a few of those as we go along through this deck. The one new thing here in 2012 R2 is the support for VRSS, which can basically enable a VM to better handle large amount of traffic, spread the incoming network traffic from between multiple cores within the VM. And it's called VRSS, and it requires that the NIC that supports it, the NIC that actually does the traffic at the end, is RSS enabled. So this is a new thing in 2012 R2. Let's talk about storage. I kind of started with an approach of the cloud needs to look like as a compute separated from storage, but let's challenge that for a second and then see where we land. So there really, if you look at storage and you look at the primary design consideration of how my storage architecture for a hosted cloud is going to look like, there are two directions that you can go, right? On one direction, you want to say, I want to have units of compute with storage integrated in them, many of them. That's my storage. When I want to grow capacity, I add units of compute and storage together. The other approach is the one where you say, I need the flexibility to go and add compute separately from storage. And let's look at how you can do each of these in a typical cloud environment. So, and Windows Server supports all of them. So I'm trying to do this is everything that you could do, and then for the problem of IaaS, what would make more sense to do? So, if you're going to build Hyper-V servers with basically internal disks in each of the Hyper-V servers, you can definitely do that. We have that. It's even potentially a common practice and a reasonable design decision to make if you don't need infrastructure high availability and you think that you can grow both compute and storage capacity together, and you can kind of like predict that they will need to be growing in a similar pace. So you can have Hyper-V servers with internal disks. In 2012, we enabled a new scenario, which is connecting your SAS disks, shared SAS disks, to multiple Hyper-V servers. Storage spaces will be used here to basically allow those Hyper-V hosts to share the same JBOD, same storage pool. And you actually get H8 because now the JBODs are connected to multiple hosts, and you have the HA now here. And you can get to a units of scale that actually are kind of reasonable. Totally doable. There is an explanation of how to do that. If you are comfortable with that, like great choice. I think that for IaaS, probably not the exact scenario that you want, because in IaaS you want to be able to focus on the other approach, which is the independent scaling. And in independent scaling, there are really two options here. There is the option of using Hyper-V servers with SANs, iSCSI or Fiber Channel, block-based storage, offload the load to the controller within the SAN, get high IOPS. You also pay a lot of money. The new thing in Server 2012 that got even further improved in 2012 R2 is the ability to use a file server as your storage. And in the backend of the file server, have your real disks, your real spindles, your real storage. Server 2012, I have like SAS here, and then iSCSI and Fiber Channel as optional. And when we were talking about this capability in 2012, when it launched, people kept asking me, why would you ever put a file server in front of a SAN, basically? You're adding the file abstraction, and you're paying the cost of the expensive SAN at the backend. And the answer was, because you probably have existing investments in SANs that you want to keep using, but eventually you're going to move to the lower cost storage. And if we look at what happened between the time we shipped 2012 and now, that's exactly what people are doing. If you are starting a new environment and starting from scratch, and you don't have existing investment, then you'll put a file server in front of a JBOD and just use that, and that's your best cost-effective option. If you already have a lot of storage, but you want to see the infrastructure being managed in a very uniformed way, file-based access to your storage, then you do put the file server, and also you kind of like piggyback the SANs behind it, And over time, you will start changing your storage to be the more cost-effective one. So we actually see both happening. So this option is really the one that we are very much focused on enabling and making better. File-based access, lower-cost storage. If we rule out the compute and storage scale together, just because for IaaS it's usually not the right scenario, that's not what you really need, then the other option is to go with the file servers because of the cost. It is much more cost-effective, better design point. Let's talk about resiliency. So we touched it a little bit on the workload, but really the question is, what happens when hardware fails? Or more accurately, what happens to an app or a tenant VM when hardware fails? And there are two approaches. One is that you can say, hey, my infrastructure, part of my SLA, is that I will guarantee to you that even if my hardware fails, your app doesn't. And for that, I will build resilient hardware. I will put things into clusters. I would put multiple NICs. This is kind of taking it to extreme. I would put double power supplies, all that stuff, but I will make sure that any hardware, like even in the face of a hardware failure, the tenant VM are still up and running. My responsibility as a hoster to make that happen, probably a high value SLA as a result, but you can do that. The other approach is failures of the app is a problem that the app needs to solve. They will run multiple instances of the app. They will know how to fail over in case something happened. They will use application-specific failover mechanism. They will use guest clustering, but it's an app problem. Both are really valid, but one works better for the traditional apps, which is the resilient one. It's also more expensive. It's a consideration that you need to think through. I would point out that one as something that probably if you're doing IaaS today and you want to allow traditional workloads to run on IaaS, that you want to do that. I would predict that in the long run, the more the apps become cloud-aware, the less we will need highly resilient infrastructure, but we'll probably need a mix. So just think about these two options and use it as a guide for you to design the right infrastructure for you. Okay, so we've gone through the workload consideration, the network, the storage, the compute, and we want to build it. And Server 2012 days, we basically said, hey, we are shipping Windows Server. We have all of these new capabilities, and we want to guide you on how to do that and how to use them. And as a result, we came out with a representative configurations and detailed documentation of how to actually do that. Is anyone familiar with these guides or documentation? No one. Okay. I guess we didn't do a good enough job on publishing them. We actually had TechEd talks about them. It's all online. They were tested. The key thing to note about them is that really they took 3 different approaches. Because Windows Server enables you to do so many different variations of how to build the infrastructure, these 3 were kind of selected to highlight the feature through 3 different variations. One which is, if you've been doing the Windows Server 2008 R2 thing, which you had to do before, which is physical separation of networks, then you probably would go with number 1 and understand how to do it with Server 2012. If you're going to go with the file servers approach, the separated network approach for data center and tenants, then the middle one would be the right one for you. And if you want to go with the one that's based on Hyper-V, connected directly to JBods and storage spaces, then option 3 was your option. And you could mix and match. It's not like these are the only ones that work. It just was a good way to highlight the various options that you have. We have tons of documentation out there on how to do each of them, how they were designed, step-by-step of how to set them up using Windows Server UI, a script on how to automate this end-to-end with PowerShell. So you can basically run some PowerShell script, point it at a few servers, and they would become config 1, 2, or 3. from remote. Everything was documented. But if we apply the IaaS design consideration that we are talking about here to these configurations, and we say we want something that will run all workloads well, that will scale separately for compute and storage, that will lower our cost of storage, and that will give us high bandwidth network between the Hyper-V servers and the file servers, with isolation and with ability to support resiliency if needed, then you really end up focusing on the middle one. And that's the configuration that we've been focusing on improving and making better, more scalable, even lower cost, and easy to set up. Let's talk about this configuration in a few more slides just to orient you on the features that are coming together in enabling this configuration, and then we'll show how we do that in the 2012 R2 version. So, first thing is about storage. We've said that basically we are now talking about a file server that is connected to a SAS card to your JBODs. You basically pull the disks together, you put a space on them, you make that into a cluster shared volume, you scale it out, you expose it as a file share, and you get your storage side set up. In terms of the network, you have the data center network connected between your Hyper-V hosts and your file server, and you have a separate network for connecting the tenants and their VMs out to the internet. There is a session that talks more about how you actually can do this better in R2. If you look at what we've improved in 2012 R2, it's around tiering, write-back caching, the automatic redirection to the right node in the file server scale-out cluster that handles a specific pool or space. There are storage cross features. All of that are covered in details in dedicated sessions. But this is where the relevant features come together. On the network and resiliency fronts, really you had the features for DCB that can help you do offloading of QoS policies here. You can have NIC teaming. You can have the QoS to guarantee different minimum and maximum bandwidth for different traffic flows. So like, for example, if you want to ensure that cluster heartbeat always get some share of the traffic so that the cluster detects it's alive, or if you want to ensure that storage access doesn't starve your live migration traffic, etc., you can do that on the host side. And between the VMs, you can use different features called switch quality of service, which allows you to assign different policies for different VMs. In 2012 R2, NIC teaming became better. It now knows how to dynamically load or change the load between the different teams in the NIC, specifically for this case, where it sees network virtualized traffic. So it knows how to handle that better and better split the load. And there is on the resiliency aspect, we talked about it before, there is a shared VHDX feature that will allow VMs to do guest clustering using a shared file that sits here on the file server. So you can do guest clustering over SMB, basically. There is an issue between RDMA and NIC teaming. Because RDMA bypasses the whole network stack, you cannot do NIC teaming and RDMA together. Not possible. What you can do is to basically move to L3. So if NIC teaming is an L2 feature for combining two NICs together to behave like if they are one, if you want to have resiliency at that level and you want to have two different NICs and RDMA, then you can use the layer 3 ability of all of the different traffic flows to actually use the two NICs together. So you can use SMB multi-channel, which will allow the SMB stack on the server to use two different NICs in parallel. You can configure the cluster to know about the two NICs and two networks and use both of them. You can do the same for live migration. Basically, you can get the same effect without using NIC teaming. You can get to the effect where you have resiliency and you have both NICs working and the different components within Windows Server actually using both of them at the same time. SMB multi-channel has been improved mainly around performance, but also the feature of knowing how to get to the right path to the file server. SMB multi-channel has been improved in R2. So in 2012, the way to configure this thing was a lot of Windows UI, a lot of PowerShell. If you follow the documentation that we published, you can actually do that and get a system up and running. But one of the key things we've done in 2012 R2 was to align with System Center. So what I want to do now is show you how you can do that and how easy it is to set up a system like that in using 2012 R2. And for that, we have Hector here, who is from the System Center Virtual Machine Manager team, and he will walk us through how you actually set up this kind of an environment using VMM. Hector, all yours.
Thank you, Phil. Appreciate it.
While he's getting ready, we will really focus on the file server aspect of it. Provisioning Hyper-V clusters was something that existed in VMM for a long time. For file servers, that's really a new capabilities of 2012, which was badly missing before.
Alrighty. Good afternoon again. My name is Hector Linares. I'm a program manager with the Virtual Machine Manager team, and I'm going to take you through a quick tour of what is supported in Virtual Machine Manager R2 around deploying physical servers. And so what you see here is the R2 console, and I'm in the Fabric workspace. So Fabric workspace for us includes compute, storage, and networking. I'm going to focus right now on the storage side. So you see I already have a file server provisioned in VMM. So the way that I actually deployed this is using the OS deployment, or OSD. How many of you are familiar with Hyper-V OSD, bare metal deployment of Hyper-V using VMM? No? Okay, so the way we would do this in 2012 RTM, SP1, sorry, is to deploy a physical server or a Hyper-V compute cluster, is to go in and first go to the library. So we have what are called, in SP1, these were called VM host profiles. We made them now generic, and now they're physical computer profiles. And so I'm going to create a physical computer profile. So I'll right-click and create one. So we have two roles that you can install using VMM. And so the first one is a VM host. And again, this VM host is the Hyper-V case. And so if I select that and hit next, I can select the VHD out of my library. And here I would go through the work of setting up the network. So in this case, if I wanted to set up a virtual network that would be part of a vTeam or a NIC team, I would set that up here by adding a virtual network adapter. Sorry, I don't have a logical switch. So I would add a virtual network adapter, I would have all the settings, and then I would also configure my operating system, and then that would be the profile, or essentially what I want to stamp out for every physical machine. So that would be for the Hyper-V cluster. We've done the same for the file server. So in this case, I've already got a pre-configured file server profile. It looks very similar. I've got a VHD that I want to deploy. I've got the way that I want to configure my network and my operating system, sorry, the OS disk, and also the operating system. And all these settings equate to an unattend.xml file. So I've got my domain, I've got the password. If I've got a product key that I want to put in, I can do that here. So I've got a profile now. Now I need to actually go and deploy something into the actual infrastructure. So I'll switch back to Fabric. So if we start this journey, we don't have anything added into VMM. These are going to be physical servers with no operating system that I want to deploy an operating system to and then configure storage. So the way I would do that, I would go onto the ribbon and hit Create. And so the SP1 in RTM, we would have Hyper-V cluster creation. Now we've got file server cluster creation. This is a new feature in R2. When I click on that, I launch the wizard that it's actually going to deploy the scale-out file server. So if I have, let's see, demo class 2. So I need to name the two network entities. So one is a cluster name, and then the scale-out file server. Now, I can deploy a scale-out file server two ways. Either I have an existing file server, an existing server already on the network with just a regular Windows installation. That would be the first option. We go off, we recognize that the server is available, we install our agent, we'll enable the failover cluster role, we'll enable the file server role, we'll cluster the nodes, create the scale-out file server, and then bring it under management. The more interesting case is if I have physical machines with no operating system. So in that case, I will pick the profile that I want. And here I've got to tell VMM which physical machines to actually go and talk to. And for that, we communicate with the baseboard management controllers, or the BMC cards. So you would see an Dell DRAC or an HP ILO, for example. Using standard space management, we communicate with these cards. I pick my protocol, I hit next, and then I would give VMM the range of IPs to go on the network. And these are not the physical, this is not the OS of the physical machine, this is the baseboard management controller. So I would give it the IP address list and go off, and it would go and find them. So the end result of this workflow, after it finds the servers, it's going to go off and power them on, deploy set up the local disk, deploy the operating system using boot from VHD, and then the similar workflow is as if I had an operating system. We're going to enable the role, the failover cluster role, we'll enable the file server role, we'll cluster the machines, we'll cluster the machines, bring it online, install, get the file server, scale out file server role created, and then bring that under management. And so what you would have after that workflow is a scale-out file server under management. So that's the first piece. I've deployed my operating system, I've deployed the file server. So now I actually want to go and configure the storage. So when you click on the file server, in the ribbon you'll have a manage pools option. I've already got a manage pool here, but I can also go new. So in this case, we're using a new provider developed by Windows Client and Windows Server that actually allows us to have a unified cluster view of a Spaces cluster. So in this case, I've got a two-node, essentially two physical servers connected to SAS storage. And so I have, through one provider, I get to see the fully unified view. So in this case, I've got a bunch of disks that I want to bring under pool. So we discovered this through the provider. These are physically connected, so there's really no configuration up to that point. So I select the disks, give the pool name, and I hit create. So now I'm going to go off and create, or under the covers, the pool is actually going to go off and get created on that cluster. And this will be a clustered Spaces pool. I haven't created Spaces yet, an actual, the equivalent of a LUN. And so now that pool is created, we'll flip back to Fabric. Now we're going to do intent-based file share provisioning. So one way of doing this is to create a space, make sure it's clustered, and then you go initialize partition, format the volume, bring it into the cluster, make it a CSV, and then add a file share. So we've simplified that process by going to create, file share. So I've got my scale-out file server. I am going to pick a name for my share. I want to create this on demo 4, which is the pool I just created. You don't have to assign a classification. You can if you want to. Otherwise, we'll inherit from the underlying pool. Give it a size, pick your file system, NTFS or REFS, and hit create. Now, what will happen on the underlying cluster, so if I flip over to disks. Yep. So we're going to go off and talk to the cluster spaces. We're going to go create the space. We're going to bring that space as a cluster space under management in the cluster. That's what and we'll make it a CSV. And then under the role, we're going to go off and create the file share. So within a few seconds, you'll see the MS TechEd 01 file share pop up here. And now I've got a scale-out file server share ready to go. And the last piece is to go back into Fabric. And now I actually want to expose it to my cluster. So I'm going to right-click on Demo Cluster 01. This is my Hyper-V compute cluster. Go to Properties. So you can expose different types of storage, either LUNs or CSVs. In this case, I'll click on File, Share Storage. I'll click on Add. And then I'm going to pick MS Tech, I think, yeah, it should have been TechEd. Sorry, MS Tech 01. So this is the file share that I just created on the pool that was provisioned using the physical disks that were discovered using the cluster aware provider. So when I click on this and hit OK, we're going to go off and then make sure that we have all the right computer accounts ACLed to that share. And we'll also add our own accounts so that we can do normal management, VM deployment, et cetera. And so once you have that fully configured and deployed, now you can start deploying VM workloads onto that file share. Now those workloads could be standalone workloads, non-HA or non-highly available workloads. They can also be highly available workloads. So if you wanted to make sure that the VM can fail over in a cluster, you can also use a file share for that in the back end. And so that is how you would go from creating your compute clusters for Hyper-V. You can then also go and create your scale-out file server clusters, configure the storage, prepare the shares, and then ACL them to your compute. And that's the end of the demo. Thank you.
Thank you. So, what do you think? As you can see, this is really this has become much easier by the integration between Windows Server and System Center, enabling those features to be lit up and used in a very easy way. Now, the way we've basically said how to do this configuration with Windows Server was a combination of Windows Server UI, but also PowerShell, because in a cloud environment, you want to automate that. You can PowerShell or automate PowerShell against VMM, and you get a higher level of abstraction. So instead of PowerShell configuration for every small features, you basically can get talk to VMM and then do, I want to use PowerShell to automate the provisioning of a computer profile onto these servers that are going to become my file servers. So even the automation became easier with this VMM acting as the place where you work with higher level of abstractions, more basically in your language. So talking about scale, if you want to scale this thing and you want to basically add more capacity, and as a reminder, we're still talking about the infrastructure, which is where I said most of this session will be about. A scale unit is really the same thing, just bigger, right? So very similar consideration. You can use the management stack, VMM, in order to provision additional compute host or additional Hyper-V host, additional storage, and add more capacity as you go along. When you're scaling, you do need to think about some other things. So you get to the question of what is the cluster size that I want to use, and a key area where Windows Server 2012 really changed and improved was the support for larger clusters. You can build clusters of 64 nodes instead of, I think it was 16 before. You can consider clustering across your failure domains or across the racks. If we go back here, then a cluster could actually span units, right? It doesn't have to be this thing needs to be a cluster. Maybe you want that so that if one rack fails, you still have a cluster up and running. Your storage clusters are going to be like smaller, right? They are basically file servers, scale-out file servers. Usually, if you want HA, you'll have a 2-node file server. You can go up to 4 with JBoss with shared SAS for 4 nodes. Beyond that, it really doesn't make sense. So your file server clusters will still be like 2 to 4 node clusters. And you obviously need to think about the network infrastructure between those racks or between the scale units. And you need to design it so that there is good traffic bandwidth going on between those scale units. One thing to think about is that if you're using RDMA has different variations of this protocol, and some support cross-subnet routing, so RDMA routability, like IWAP does, but if you're using the Rocky standard, it doesn't, so you'll have to design an L2 network across your racks. Just make sure that you give this thing a proper thought. And you want to have a network for out-of-band management maybe, so like access to the BMC, et cetera, may be a different network depending on the hardware you choose, the approach you take for networking. So if there is any doubt about the ability to scale, that was an area where Windows Server dramatically improved. We basically, and you would notice that there is no R2 here, because we've gotten to a point where this is non-issue anymore. You can build basically larger cluster, use larger hosts with much more logical processors in them, much more memory in them, and much larger VMs. And the investment in 2012, the improvement factor, was enormous. And if there is any doubt about scale, there really shouldn't be anymore. Let's talk about some of the other areas, and I'll just give you a few pointers for further deeper information. As I said, covering everything in one session is practically impossible, but let's talk about each area just a little bit. So your tenant VMs will need access to the network, right? And they want to basically go through some gateways or VPN into your customer premises. What we've done in 2012 was that we added support for this site-to-site connectivity. But you had to set up a gateway VM per tenant. Okay, so if you're a hoster and you're provisioning multiple tenants on your infrastructure, every tenant that came in and wanted connectivity, you had to provision a dedicated VM to act as the gateway between that tenant VM or the tenant VM subnet, if it's a single tenant, right, to their premises. In 2012 R2, we've made this gateway multi-tenant, and we've added support for network virtualization in there. So now you can set up tenant gateways as much as you need per your capacity, but you can set up basically one or in HA mode, two multi-tenant gateways, and then route all of your network traffic through these multi-tenant gateways into their respective corporate sites. And guess what? System Center can actually provision those gateways for you. So that's also easy. And you get the benefit of a Windows Server multi-tenant gateway feature. You can basically think of it as, I'll just provision these VMs onto my cloud fabric as VMs that are going to act as network gateways. I own them, I manage them, but they are multi-tenanted, and I can use them to provide my tenants with a service of connectivity of site-to-site connectivity to their premises. So there are 2 sessions that you can go to learn more about that, both about how you do like the core technology of Hyper-V network virtualization and how the gateway plays a part of that, as well as how to do this with VMM and configure that. If we're talking about management, so there are actually 2 areas that I want to talk about. One is the Windows Server improvement, and on the Windows Server improvement, there are 2 key technologies that you need to be aware of. The first one is the data center abstraction layer. And what we've done there is we've basically said there needs to be a standard way to manage all of the equipment in the data center, in this cloud that we're building together here. And it needs to be standard-based, so we are using standards like SIEM, SMIS to talk to storage devices, to computers. But the new thing here is that we've also introduced support for, we've worked with the switch vendors to introduce OMI support so that you can use standard OMI and WSMAN to talk to the switches and manage them. And instead of having different ways to talk to different network devices, now you can talk to all of the OMI-based network devices in a standard way. There is a logo program that's being created for Windows Server 2012 R2 that will allow switch vendors to certify themselves against that. We've made OMI open source, so it's easy for them to actually do that. And the session just before this one had a demo of how you do this with an Arista switch. But think of the abstraction here and the ability of the management stack to use this infrastructure improvement to talk in a standard way to any device in the data center, and how this changes the management experience and your ability to automate things across the data center. Instead of having to talk to different devices, different equipment in different languages, now you can basically manage it all through PowerShell. That's the end benefit of that. Another key feature that was introduced in 2012 R2 is called desired state configuration. It's really for the DevOps scenario. It's for allowing you or your tenants to do it on those VMs. It's actually usable in both cases. to describe in a descriptive language what configuration do you want to have on a given server, and then DSC will enforce that and will, for example, install missing packages, reconfigure things that drift away of configuration. If you went in and changed some configuration and forgot it that way, DSC will bring it back to the expected state. A really good technology. There is a session about that you can go and learn more about if you're interested. Going from the management from the infrastructure to the actual management, if you look at what we have as part of the Windows Server and System Center technologies, it's really a complete management stack. All of the infrastructure roles that you need in order to manage a cloud like that exists. So in Windows Server, you have the AD, DNS, DHCP, WSAS, WDS, all of the key technologies that you need to make sure that at the core level, things are functioning. And then on the System Center side, you have VMM for fabric management. Then you need to monitor it, so you can use Ops Manager. And if you want to orchestrate things around this cloud environment, you can use the new orchestrator, SMA. You have the backup abilities with DPM. You have the APIs and portals with SPF and the Windows Azure Pack, which we'll talk about more in a second. SQL obviously is there. If you build a system like that, you basically end up with a full end-to-end working solution. There is no missing functionality or something that we don't really offer as part of the Windows Server System Center suite to allow you to build a complete cloud that you can go and operationalize. Last but not least, your tenants want to connect to that cloud and have a good portal experience as well as a ability to talk to APIs through RESTful APIs. And we've just introduced the Windows Azure Pack, which what it really does is it allows you, it takes all of the learning that we've been learning from Azure and taking that and making it available to you in a way that will enable your customers to have a consistent experience across clouds. So the CloudOS consistent experience is really delivered by the Windows Azure Pack. And the way to think about it is that in Azure, we've been building the Microsoft public cloud running on Windows Azure with an API that you can talk to, with a portal for the subscribers, and with a range of services that we offer to our customers. And what we're doing in this release is we are taking the same infrastructure, the same hypervisor that runs in Azure is also obviously running in Windows Server, so that's Hyper-V. Adding the layer of management with System Center allows us to basically become the fabric management for the on-premise cloud, the service provider cloud, the hosted cloud here. We've taken the same APIs and make them available to you so that you can expose a consistent experience to the tenant so that they can go and have a common management experience when they are consuming a hosted cloud. We've taken the same portal and made that available to your customers. So if you deploy the Windows Azure Pack, your consumers are getting a very similar experience to what they get when they go to Azure. Plus, we've also built a provider portals for you to manage the services and offerings that you are going to expose as part of your hosted cloud to your tenants, to your customers. And we didn't stop there. We also took the advanced services that we're offering in Azure and started to move them into the hosted cloud environment so that you can deploy that and you can offer websites, VMs, SQL, Service Bus, and future services as we build them in Azure, we will deliver them to you. So all of this means that as a tenant, I get a consistent experience across different clouds that are powered by Microsoft. The private cloud, the service provider cloud, the enterprise cloud are all going to be consistent with each other, and your customer experience becomes better as a result. There is a session about that, but I think somehow the pointer got lost. But if you look for the Windows Azure Pack talks, there are a lot of talks about that. And that's the consistent experience. So to summarize, with Windows Server, we've built the foundation. With R2, We've improved that, but Windows Server is really the foundation for your hosted cloud. Service System Center provides the management stack that you need. So all of the components for management that you may need as a hoster building a cloud are really there. And with Windows Azure Pack, we've delivered an experience that is consistent across the different clouds, and we've made it available to you to offer to your customers so that they can benefit from a consistent experience when they are consuming the multiple clouds that are built on Microsoft technologies. And with that, I have a list here of a lot of sessions that you may want to go to and attend, depending on the area that you're working on. But what I've tried to do is really give you this broad view with a deep dive into the Windows Server piece together. I'll be later at the expert table in the expo floor later today. I tweet if you want to follow me. And feel free to ask me questions over email or here. And with that, I'll open it up for questions here. Thank you. So any questions? There must be someone brave. No? Okay. Thank you very much.